I'm continuing with the simultaneous equations. Last time there was a equation of a circle on a straight line. This time I want to have an equation of a parabolic curve with a straight line. For sake of argument, let my parabolic curve be x squared minus x minus 1, and my line y equals 2 minus 3x. I will number the equation 1 and 2, because I need to refer to them throughout the solution. We always go to the line equation, and we make either x or y the subject. But the y is already the subject here for me, so I'll use it. And I will inform whoever reads my solution, maybe the examiner or someone who wants to know the procedure, that I'm going to substitute y equals 2 minus 3x in equation 1. Equation 1 I shall write, and I'll do exactly what I've said. I'm going to substitute y as 2 minus 3x in this equation. So all my y's will be replaced with 2 minus 3x. I shall now move all these items to the other side, or all these items to this side. But since I want to start with the quadratic equation with the positive coefficient of x squared, I shall move this to the other side. Remember, change side, change sign. So 0, x squared minus x minus 1, move 2 to the side becomes minus 2, and minus 3 to the other side becomes plus 3x. My equation would be, after being simplified, x squared plus 2x minus 3. Now, by looking here, I can see that this equation does not factorize. Or maybe it does. I think it does. Question mark plus question mark. I'm looking for two numbers add to give me plus 2, and times to give me minus 3. Two numbers times to give me 3 must be 1 and 3. They must multiply to give me minus 3, so 1 has to be plus, 1 has to be minus. By putting minus before 1 and plus before 3, it satisfies both conditions. Minus times a plus is a minus, 1 times 3, 3. Minus 1 plus 3 is 2. So here I can factorize the quadratic quite nicely, actually. So that 0 could have been over here. I've got two terms multiplied to give me 0. Multiplication of two terms is 0. One of those, or both of them, the cause of that 0. So either x minus 1 was 0. Therefore, if you balance the equation of moving minus 1 to the other side, x equals plus 1. Or x plus 3 was the cause of 0. By balancing the equation, x equals minus 3. So these are the 2 points of intersection, the x coordinates of the 2 points of intersection of that line and that parabolic curve. We need to know what y values they possess. So when x equals 1 or plus 1, I can use either equation. I can either use this one or that one, because that point belongs to both of them. So I use the easy one. When x equals 1, y equals 2 minus 3x, that's equation number 2. And I substitute. Y equals 2 minus 3 lots of 1. So y equals 2 minus 3 equals minus 1. So one point of intersection has the coordinates 1 minus 1. And the other point would be when x equals minus 3. Using the same equation to substitute in, y equals 2 minus 3 lots of minus 3. Y equals 2 plus 9. So y equals 11. Therefore, the other point that the line and that parabolic curve meet would be point with the x coordinates minus 3 and y coordinates 11. That would be the end of this question. I'm going to create more questions now, just to improve our technique. Let's have a look at a different equation. Another example with quite awkward numbers. My line is 2y minus 7x equals 2, and my equation of the curve is 3x squared plus 2xy minus 6 equals 0. Equation 1, equation 2. That is a straight line equation, and this isn't. This is the curve. Now, need to make either x or y the subject. If I make y the subject, I will have 2 plus 7x all over 2. If I want to make x the subject, it would be 2y minus 2 over 7. I think it would be easier if I make y the subject. So from equation 1, two y minus 7x equals 2. I'm trying to make y the subject, moving minus 7x to the other side. And making y the subject. So I'm writing y in terms of x. Then I'm going to substitute y equals 7x plus 2 divided by 2 in equation 2. So this is a quite hard one because the numbers aren't very friendly, and we have x squared and x and y all mixed together. But the procedure is the same. So all my y is going to replace at my x. So equation 2, I write it again so you can see when I substitute. So we have 3x squared, 2x, and y is 7x plus 2 divided by 2 minus 6 equals 0. Fortunately, that 2 and that 2 will cancel. So our equation is not as bad as I thought. Multiply x times 7x, that's 7x squared. X times plus 2 is plus 2x. Minus 6 equals 0. I'm going to tidy this up. We have 10x squared plus 2x minus 6 equals 0. Fortunately, again, I can divide all these terms by 2 because it makes my life easier. I can divide both sides or every term of the equation by the same number. So I can use smaller numbers. So that becomes 5x squared plus x minus 3 equals 0. I'm just thinking whether this would factorize. B squared minus 4ac, ac is 35, 15, 15, 60, 60. No, this does not factorize. So I have to use the quadratic formula. For those who are not familiar with the quadratic equation formula, a is the number which is the coefficient of x squared. So a is 5. B is the number multiplied by x, or the coefficient of x, which is an invisible 1. And C is the constant on its own. And the formula is x equals minus b plus or minus b squared minus 4ac divided by 2a. I'm now going to substitute. Minus b. All substitution inside bracket. If you want to enter that in the calculator, you need to enter with the brackets. That makes sure that nothing goes wrong, especially when you're squaring a negative number. That must be inside the bracket. B squared minus 4, a being 5, and c being minus 3. Make sure your square root covers everything, over 2a, which is 2 lots of 5. Now I can go directly into the calculator or make it a bit simpler before I give it to the calculator. You don't have to simplify. If you use the calculator and use the brackets appropriately, you get 2 answers. One answer when you use the plus sign, and one answer when you get a negative sign. Or you can write it as exact value, like here, minus 1. 1 squared is 1. Minus times minus plus. 4 times 5, 20. Times 3, 60. Over 10. So we have minus 1 plus or minus square root of 61 over 10. As an exact value, we have 2 values for x. X would be minus 1 plus root 61 over 10. And minus 1 minus root 61 over 10. I'm going to write these as decimals in... Sorry, that was a 10. So, negative 1 plus root 61 over 10. 0.68. And if we go back and change the positive sign to negative, it gives me minus 0.88. Now we can find the corresponding y values. When x equals 0.68, look at our substitution. Y was 7, x plus 2 over 2. I write it here again. Y equals 7x plus 2 over 2. And I'm going to replace 7 lots of 0.68. Divided by 2. That would be 3.38. So these two make a pair of coordinates, 0.68 for x and 3.38. That's 1 point. The other point was x equals minus 0.88. So when x equals minus 0.88, y, same equation, 7 lots of minus 0.88 plus 2 divided by 2, which gives me minus 2.08. So these two make a pair as my second point where the line and the curve meet. So we can call this point A and point B. These are the answers to solving that pair of simultaneous equation, one linear and one non-linear. I have done a few of these. Of course, every question is slightly different, but the technique would be the same. The technique is to go to the linear, make either x or y, whichever convenient, the subject, and replace it into the non-linear. Could be equation of circle, could be parabolic, could be hyperbolic, it doesn't matter. The technique would be to replace for one of the letters, so you end up with an equation in terms of just one letter. Here the y has been replaced, and I ended up with an equation which is just in terms of x. So when I solve this either by factorization, it factorizes. This time it didn't factorize, so I used the general formula for the quadratic equation. That gave me the two values of x, and I found the corresponding value y for each x coordinate which I've obtained earlier. And that would give me the 2 points with their x and y coordinates. I hope you've enjoyed this question. And next topic, I shall do a new topic. Maybe later on I can do more quadratic equation, but if you request it, I'll do it. Meanwhile, I hope you've enjoyed the lesson. Till next lesson, thank you.